This video is strictly for people with an interest in vintage workshop, home workshop equipment, metalwork. If you're in here for politics or you joined the channel for politics, it may not be for you. Don't bother unless you're interested in it. This is the lathe here, the Shenhua 90 lathe, and this is a top slide which I fabricated myself out of mild steel. This is the commercial variety, possibly for a Myford lathe. Very good too, not just as versatile as the one I made myself, but it gives you an idea of what the commercial one looks like. And it bolts down on the cross slide. Anyway, I'm not using it for the moment. I have actually bought it for €25 at the Variety Mart, and I'd love to get using it, but I haven't. Anyway, this is my own creation here, and I have a plate bolted here. You see, and when this here is in the center, when this is flush, an Allen key goes through here, an Allen screw, and you can tighten up the slide up to the back here. You see it protruding out here. Look at it here. And then you can tighten this and tighten a couple more, and you have a very rigid arrangement. Now, so strictly speaking, you could turn that at any angle. Do you know what I mean? You could turn it at any angle you like, but I have it straight up at the moment. Now, here on this is a dividing plate. This is a circular plate with 12 divides, and you line up each divide up to any notch you like here once you get the first one going. So you can divide by any divide of 12. So you can divide by 12, by 6. You can't divide by 5. You can divide by 4. You can divide by 3, and you can divide by 2. And of course 1. Well, you can divide 1 by them all. It's not relevant. So you have again. You have 2, 3, 4, 6. And 12. You have 5 divides there. Now you might wonder what that's for. Now I have a milling cutter in here. So one of the applications for this would be if you wanted to make a hexagon bolt. So there's the bolt here. You'd set these settings. These here mean that you can set it to a specific range, and you can tighten these so tight that this here cannot move. Now, sometimes I do apply a G-clamp over this side to just tighten it up as well. Now, if you're dividing, if you wanted to make a hexagon nut out of this, a hexagon, maybe this would be a better example here, a hexagon. See this here, this cutter. You'd set it up, and then you'd run a cut off the 6 sides. You turn this 2 every time so that you had 6 sides, and then you'd mill it with the milling cutter, or even a different milling cutter than that. You'd mill it with the milling cutter there. Now, another application would be if you had a top of a cylinder of a steam engine, or even a small model engine, or anything that is not too big. Now you'd go 5 inches there max, I'd say. You have to have an arrangement to fit this in. There's several housings turned up from steel or aluminium, and these are tightened in, and there's a lock put. This plate here has a hole over here. Do you see it here? And that's to lock it so that it can't spin. Well, then when you have that done, you can then divide, and if you wanted to put we'll say 4 holes, 1, 2, 3, 4, 3 holes, no problem, or 6 holes. You can subdivide the top so that you'd have bolts going down to bolt down the cylinder head. You see it here now again. So you'd make a cylinder head maybe. So here's the screw of an angle grinder. Do you see the way it's subdivided? See, there's 4 holes. So if you wanted to make that angle grinder, you could turn that up out of steel, no problem. You could thread it with a tap, or indeed you could thread it on the lathe, whatever thread it is. And then you need these holes. So that would be ideal. You will, by going 3 notches, you divide this by 4. And so that's a typical example of where you'd use this to drill those 4 holes equidistant. Now, of course, you'd have everything totally centered, with a dial gauge to indicator to make sure that everything's centered. But once you have it attached to this is made a tight fit. This cannot wobble much. This is made a tight fit for this. So there's only very, very minimal play at all in it. Nearly none. In fact, I've made it a very tight fit. Now, so that's dividing. There's a thing called a dividing head, which uses a worm gear, and you have a plate, and you can get up to 50 different divides. But for practical purposes, this is good enough. It just doesn't have 5. You can't have 5 with 12. You can only have something that will divide into 12 equally. But a grand job. I did a lot of bits of work on it. You can mill in it, you can drill, and you can, as I say, this is just for the ordinary person. There's the hole. See them there. That's it there. To make that, you'd use this setup, and you just adjust it. And when you have it adjusted, then you tighten these bolts tight and give it a bit of its time, and you'd make sure you have this set here that it can only go the amount you want. And when you get that done, then you can take the nut out and you can give it a run of the file and just tidy it up, or you can whatever you want to do. But it's an idea. It's called dividing, and milling machines usually have dividing heads as well, and there's some very fancy type of ones, but this is the way I do it. This is the screw here. See it there? I redone that screw because the original one got a bit battered on it, and I put in this one. You can buy them. They're trapezoidal, you call them. And so, yeah, grand job, and all homemade and working grand. The main thing is not to let angle grinder dust in here. Not to let angle grinder dust. And in the best form, these here should be cast iron. You're better off with cast iron against steel. But steel works against steel too, and works good enough as long as you keep it lubricated. Sometimes it will gall. There's several items that work with steel against steel. A shotgun, under and over shotgun is an example. And if you don't keep them oiled, they could stick a bit. But certainly cast iron is never used in things like that. But for this application, cast iron would do. And I made them out of, those G-clamps. The Chinese G-clamps. I milled them down in this, so I made my own. They call them jib strips. And then the fit, you see the way it fits in here? See the way it fits in there? That's the way they work. So you just copy what's there. You don't try to reinvent the wheel. You just copy what's there. And then this can go in and out this way. And then you can bring it up like that, up and down. And that's the same action as a milling machine, only on a different plane. We'll see you back soon, folks. Thanks.